Today, we're diving deep into the performance of the NVIDIA GeForce RTX 5090, specifically for demanding AI and machine learning workloads. We're not just gaming, we're pushing these GPUs to their limits with large language models and intense stress tests. The RTX 5090 is a beast, packing a massive 32 gigabytes of VRAM. At idle, a single card is pretty reserved, consuming around 18 watts of power with a temperature hovering around 40 degrees Celsius. That's about 104 degrees Fahrenheit. But today, we're doubling down. We have two of these cards in the machine, giving us a good amount of raw, untapped horsepower to try out. So let's dive in. We're going to be using three large language models with varying levels of parameters. First, we have the Llama 7 billion parameter model. Next, the heavier Llama 34 billion parameter model. And finally, the massive Llama 3.1 with 70 billion parameters. Let's see how they measure up on the RTX 5090 using Ollama for inference. We're running a simple test setup here. Each model gets a quick warm-up request to load into the GPU's memory, followed by the main benchmark request. We're watching the key metrics, tokens per second and characters per second, which reflect the GPU's utilization efficiency. First, the warm-up request for the Llama 7B, and now the benchmark. Took no time at all. The Llama 7B finished in just under half a second. It generated 181 tokens, 427 characters, at a rate of over 900 characters per second. This model is effortless for a single 5090. Now it's moving on to the warm-up request for the Llama 34B model, and this is real time. You can see the live stats for the GPUs running on the right, so we can track exactly how hard we're driving them. Okay, not bad. Sub 2 seconds for the Llama 34B full trip. We're seeing about 48 tokens per second or 265 characters per second. Now it's warming up for the Llama 3.170 billion parameter model. Okay, it's done. The 70B model took a total of just under 25 seconds to run the warm-up and the benchmark. We're getting about 3 tokens per second here and almost 18 characters per second. Definitely slower than the others, but that is to be expected. This model is much heavier than the first two, and it almost completely consumed the VRAM on our single card, using close to 30 gig of the 32 gig available. The single 5090 can handle it, but it's a tight squeeze. Now let's try streaming with that large model to see what the actual user experience looks like. We'll give it a simple prompt and go. Considering the sheer size of the model, the performance is honestly pretty good. I ran these a few times and found the average for each one. The table clearly shows that Llama 7B was a speed demon that barely taxed the GPU. Llama 34B maintained a great speed while requiring a bit more juice. The main takeaway, however, is Llama 3.170B. It performed slower as expected from a model of its size, but it maxed out the VRAM, consuming almost 30 gigabytes. The exciting part is that even this massive model can be run on a single graphics card. The key takeaway from the Ollama test, a single 32 gigabyte GPU like the 5090 handles models up to 34 billion parameters effortlessly, delivering high throughput. However, for a massive 70 billion plus model, you really start to push the limits of a single card. This is where the dual RTX 5090s shine. A quantized 70 billion plus model often requires 35 gigabytes to 45 gigabytes of VRAM, which pushes a single card to its limit of 32 gigabytes VRAM and forces slow system memory swapping. By using Llama CPP to split the layers across both cards, we eliminate that bottleneck, jumping performance from a painfully slow 3 tokens per second to a performant 15 to 30 tokens per second across both. Dual cards unlock the ability to run these ultra-large models at full speed without compromises by keeping the entire model in fast GPU memory. Now let's use GPU burn to really stress the GPU cores and memory for a stability check. Since GPU burn uses CUDA, it fully stresses the cards just like real ML or compute workloads. We'll run it for 60 seconds here. You can see we are using over 1,000 watts with these two cards, each at 100% load. We're pushing around 20,000 gigaflops a second to each card. In just 60 seconds, we went from around 65 degrees Celsius to a peak of about 86 C, around 186 degrees Fahrenheit. All right, so I reran this test, but this time for a full 15 minutes. I'll spare you the entire runtime, but let's jump right to the halfway mark to see where we landed. The temperatures are still holding steady, 88 Celsius on one GPU and 84 C on the other. That's right where we expect them to be. Now, checking the other key stats, we can confirm we're running on PCIe Generation 3. Both GPUs are locked at 100% utilization, and we're consuming roughly 28 gig of that available 32 gig of VRAM. And just to reiterate, we're still looking at those manageable temps around 84 degrees Celsius. Perfect. Now that we've pushed them hard, let's let the cards cool down a bit, and then we can really dig into all the detailed stats we've gathered. So here's the final conclusion after all those stress tests. Both GPUs handled that full prolonged load without a single error. They proved they are stable, performing well, and perfectly capable of crushing any intense machine learning or high-performance computing workload you throw at them. But before we wrap up, let's look at one final real-world scenario, running 2 independent Ollama instances, each using the large 34 billion parameter model with one instance dedicated to each GPU. What did we find? A single RTX 5090 can easily run that 34B model, hitting about 100% utilization and using around 21 gig of VRAM. That still leaves us with about 11 gig of headroom, which is plenty for slightly bigger request batches. Now, with the dual RTX 5090s running 2 separate instances, we saw full utilization while maintaining completely safe power and thermal margins. Check out the temps. GPU 0 was at 80 degrees Celsius and GPU 1 was even cooler at 67 degrees Celsius. Power draw, crucially, stayed safely below that 575 watt limit. The big takeaway here is this: dual GPUs let you do parallel processing of much larger workloads or multiple concurrent tasks, and you get stable performance with safe thermals. Ultimately, the single RTX 5090 is an incredibly capable card. It can reliably and efficiently handle high-end machine learning and large language models, like the Lava 34B. It is absolutely optimal for serious large-scale machine learning. But throw in that second RTX 5090 and you now have an even more capable setup. Dual GPUs scale smoothly, unlocking the ability to run truly massive models like the 70 billion parameter Llama 3.1 smoothly, or allowing you to run multiple heavy workloads in parallel with full reliability. If you're building an AI rig today, the RTX 5090 is a powerhouse, and 2 of them gives you the freedom to tackle virtually any modern machine learning